Okay, Ji, this is complex number lecture number 9. So we'll be starting off with the third part of the diagram version of complex number, that we'll be taking out the angles. We can say this as argument from a point. Now, if I say that argument of z minus 0 plus 0 iota, that means we are talking about what? We are talking about the origin is equal to pi upon 4. So what does this mean? This means that there is an axis, real value of z. This will give me imaginary value of z. 1, 2, 3 iota, 2 iota, 3 iota. And let's say there's a line because x is there, so we create a line. Let's say this is y is equal to x. The angle of this particular thing will be pi upon 4. It will go anti-clockwise, so the angle is pi upon 4. Because if the line is y is equal to x, so that means at each point of x, it is crossing the origin. So at each point of x, if you note, this is 1, 1. This will be noting that this is 1, 1. This will be 2, 2. This is so 10 inverse 3 upon 3 will be 10 inverse 1. So knowing that 10 inverse 1, so this should be what? Pi upon 4. So this will be the line y is equal to x. Now considering, let's say the question states that argument z minus 2 plus 3 iota is equal to pi upon 6. Now you need to understand that, let's just do this on the other side. The question is that argument z minus 2 plus 3 iota is equal to pi upon 6. So if we just draw the axis part, this is real value of x, real value of z, and imaginary value of z. Noting that this is 1, 2, 3, 4, minus iota, minus 2 iota, minus 3 iota, minus 4 iota. Now the point is 2 minus 3 iota. If we just change it down, so this is 2 minus 3 iota will be point here. So this is 2 minus 3 iota. So the angle of 2 minus 3 iota is pi upon 6. So if the line goes here and we draw it like this will create another angle. So this particular angle will be pi upon 6, because normally whenever it is due from the point, it will be the angle. It will have what? First quadrant, second quadrant, third quadrant, fourth quadrant, because of the circle. So if we just draw this thing, we know that this will give me the angle of what? Pi upon 6. So considering this, what is pi upon 6? Your pi upon 6 is, if we just say that m is equal to 10 theta, right? And this should be 10 theta, 10 pi upon 6. So the answer is what? 1 upon under root 3. This is change in y and this is change in x. So we need to understand that any change of y will have what? Change in x. So with representing to this, we will understand that if y1 is changed, then x under root 3 is changed. That will be the change from each point of the time. Moving further, if we just say that argument of z minus 2 plus 3 iota is greater than equal to minus pi upon 3. Now minus pi upon 3 means the fourth quadrant. So if we just draw the axis, this is real value of z, this is imaginary value of z. Now noting that this is 1, 2, 3, 4, and let's say we need to change the axis. Let's change the axis because this is on the first quadrant. So this should be on the first axis. So this is real value of z. This will give me the imaginary value of z. So considering what 1, 2, 3, 4, iota, 2 iota, 3 iota. So the point here is 2 plus 3 iota. So this is 2 and this is 3 iota. But the angle, if you just see, the angle that is created is of negative. So this should be negative pi upon 3. So we don't write it negative in this, but this should be the fourth quadrant because from this point, if you just see, this will be the fourth quadrant because this shows me pi, this shows me pi minus alpha, this shows me minus pi minus alpha, and this shows me minus alpha. So minus alpha determines at this point. And similarly, if you just note with the concept relative to this, we can also work upon that tan theta. So tan negative pi upon 3 is basically negative under root 3. So negative under root 3 means upon 1. So this is change in y upon change in x. So any value with change of x will give me the change in negative f x over negative under root 3 change in y. That means towards downwards. So if it is positive x moving x, this will go downward negative 3 for each unit represented with the complex number. Locus of the complex number, let's just work out with the example. If we have z minus 4 plus 4 iota, so we just draw the diagram representing this. So the diagram will be with the real value of z and the imaginary value of z. Your real value of z is determined by x-axis. Imaginary value of z is represented with y-axis. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8. So considering this, let's have iota, 2 iota, 3 iota, 4 iota, 5 iota, and let's say we have 6 iota. So the point we have is 4 plus 4 iota. Let's say this is your point. This is your point and the radius is 2. So 2 points to the right, 2 points to the up, 2 points on the left, and 2 points towards down. So if we just create a circle, considering that it is a circle, now a circle is drawn. A circle is drawn. Let me just shape it out with a good circle. A circle is drawn from the points. Now, this is representing a circle. This is representation of what? A circle. Now, knowing, so I try to make sure that we draw a circle properly. So knowing that we have a point that is 4 and 4 iota. Now, if this is your point and stating that these are the 4 points having what? Radius. Having what? Radius. Now, stating that we need to draw a point, a line from the center of the circle. Let's say from the center of the circle to the origin. Now, this line, this is your radius. from here to here, these will be your two radius. Now, this is your normal line that will be represented to the length of what? Z. Now, the length of the Z from origin will be till the center point, that is 4 plus 4 iota, till this point, right? This is the maximum point of this line. This will be a minimum point, but this line is compared to what? Z. That means if we want to take out the modulo of Z and we use the formula x square plus y square, we actually take out the answer for this particular shape. Now, this will be the maximum, this will be the minimum, and this will be the entire minimum point. Considering at this particular this point, this will be modulus of Z, this will be the maximum of the what complex, this will be the minimum of the complex. And how do you say from this point, this would be modulus Z plus R. If you want to take out this length, right, this will be modulus of Z plus R. For this, if this is Z and we need to take out this line, this should be modulus Z minus R. So we can generate three particular values: the least distance, the greatest distance. This will be the least distance and the greatest distance. Similarly, with this help, we can also generate few other things. Now, from the origin to this point, from the origin to this point. Now, this will give me an angle. Let's say this will give me an angle. This will give me an angle, and this will be your least angle, because if this line is there, this will give me my least angle. Whereas if I just turn the scale around, moving on the other side, now this particular, if I draw a line here, so this will give me the greatest angle with the representation with axis. This will give me the greatest angle. That was the shortest angle when we talked about it. This was the shortest angle. This was the shortest angle. And this was your greatest angle. So that means two things will be taken out from this. Two things will be taken out from this. One is the model of Z greater than A less than equal to B. That means the least value and the greater value. And there will also be argument greater alpha and obviously less than, let's say, beta. So, and this Z will comprise, if we just work upon from the origin, that means 0 plus 0. So, the point here, let's say this is your A and this will be your B. This is your A and this is your B. So there would be distance of OA, there can be distance of OB, and let's say this point is your Z because of the complex number. So there would be a distance of OZ as well. So three things can be taken out into the consideration considering the distance. So if I want to just consider the distance, because Z, we already know that Z was 4 plus 4 iota. Because we know that this was Z minus 4 plus 4 iota is equal to 2. So that means the complex number is what? 4 plus 4 iota. If we just take out the modulus of Z, this should be under root 4 square plus 4 square, which means under root 32, right? So when we know that it is under root 32, so modulus of Z is under root 32. So if I want to have the greatest value, if I want to have the greatest value, or I want to find OB, this should be under root 32 plus 2. And if I want to find out the least value, that would be OA. This should be under root 32 minus 2. Because if I on the diagram note that from here to here, this will be under root 32. But if I want to find out OA, under root 32 minus the radius 2. And if I want to go till the greatest, so under root 32 plus 2. So this will give me the maximum, this will give me the minimum, and this will give me the length for the z only. Now let's just work upon the argument. So what does argument mean? Argument means the angle that we are talking about. So it will also revolve around 4 plus 4 iota. This is real and this is imaginary. So 10 inverse 4 upon 4 is basically 10 inverse 1. And 10 inverse 1 is pi upon 4, or let's just say 45 degree. So that means if I want to find out the angle from the complete angle is 45 degree. So the complete angle will be 45 degree. Now, if you understand the concept, now you need to understand that we need to have the least value. And the least value will come through the tangent, radius meeting the tangent with the origin. So this is creating a right angle triangle. This is creating a right angle triangle. And stating that we have a right angle triangle, we can always find out the angle as well, because now we know that we have under root 32 and we have the radius 2 as well. So if we just draw the line from the center to the point here, and this line is drawn as well. So this is your radius 2. This is under root 32. We can find out this angle. We can find out this angle. And remember this, since it is from the origin, so this will give the equidistant angle between the two. Now, working on this, we can always find out that whatever the angle, this will be the maximum angle from here till the point, this point will also be same. That means this angle and this angle both will be same. This angle and the greater angle will both be same. So if I just want to find out the angle that is associated inside this. So this is opposite and this is hypotenuse, because this will create a 90 degree. So opposite and hypotenuse is with the help of what? Sine. So let's say sine theta is equal to what? Opposite upon hypotenuse. So sine theta, opposite is 2, hypotenuse is under root 32. Theta is equal to sine inverse 2 upon under root 32. 2 upon under root 32 will give me theta as what? 20.7 degree. This is giving me what? 20.7 degree. So if I want to find out the angle, the least angle, this is your least angle. Knowing that this is 20.7 now, if this is 20.7, this angle will also be 20.7. And the green angle, complete angle was 45. So if I just want to find out the alpha, this would be 45 degree minus 20.7. 25 degree minus, which will be 24.3, which will be 24.3. So let's just write it down. Alpha that we need to find out. Your alpha will be 45 degree minus 20.3, 20.7, right? This is 20.7. So if we just subtract it down, so what do we have? We have 24.3. And if we want to find out the beta was the maximum. This should be 45 plus 20.7, which means it should be 65.7. This should be 65.7, which means your angle, maximum angle will start from here till here. We already know this was 45 and 20 we added, so we get the maximum angle. This will be your minimum angle. This is your normal angle from the origin, that is giving me 45 degree. So this will give me what? The maximum greatest possible angle and the least possible angle for the question. So this is what the argand and the complex the modulus and the argand angle for the given complex number.